Okay, our first review topic today is solving equations and solving inequalities. So, if you remember, an equation is anything that is equal. So, any statement that has an equal sign in it is an equation. Anything that has a greater than or less than or greater than or equal to or less than or equal to sign is your basic inequality. So, we're going to be talking about how to solve any of those things today. The whole idea when we're solving equations and inequalities is to get the variable by itself, and that is basically what we call isolating. So getting that x or y or z all by itself is what we're trying to do there. When we isolate, there's a couple of main things that we use. The first thing that we usually use is all of those inverse operations or addition, subtraction, multiplication, or division properties of equality. So we take a look at what operation is happening to the variable and we try to undo that operation using the opposite operation on both sides of the equation. So you can kind of see over here that if I do, or I have the equation x plus 5 equals 7, the operation that's happening right now is addition. So we want to undo that with subtraction. And the subtraction property of equality says if you're going to subtract on one side, then you need to subtract on the other. So we subtract on both sides and we get x equals 2. So addition, subtraction, multiplication, and division properties of equality are helpful when you're trying to undo all of those operations. The other property we usually use when solving equations is distributive property. So remember, that's when you have a term on the outside of your parentheses times a group, and you multiply that term times all of the terms inside the group. So for example, if I have 3 times the quantity x minus 2, I do 3 times x and then 3 times negative 2, and I get 3x minus 6. So we use distributive property in a bunch of the problems below. Now, when we are solving all of our equations and inequalities, everything is going to be exactly the same for both equations and inequalities, except when we deal with inequalities, so greater than, less than, greater than or equal to, less than or equal to, we have to make sure that we remember there are certain times where we switch our sign. And those times that we switch our signs are multiplying or dividing by a negative number. So you can see over here in my examples that we went ahead and divided by negative 3 in this first problem, then we were going to have to switch our sign. So you can see the negative 3 in the denominator here. That means we need to switch our sign from greater than to less than. Over here, when we subtract 3, nope, that's not switching. And if you divided by a positive 3, also not switching. So you need to make sure that you pay attention to any problems where you might have to multiply or divide by a negative number. That would be when you would switch your greater than or less than sign. All right, as a recap, when you are solving, here are the steps you're going to take. The first thing you're going to do is get rid of any parentheses by using the distributive property. So go ahead and distribute all of those things if necessary. Then you want to combine all your like terms. Remember, like terms have the same variable and the same exponent. So get the same letters together on the same side. Then you're going to get all of your letters to the same side. So if you have one on the left and one on the right, you want to move them over to the same side. Then you're going to get rid of any remaining terms by isolating your variable. Use those addition, subtraction, multiplication, and division properties of equality so that you basically get x or y or z by itself. And then finally, don't forget you can check your answer on all of these things. So there's no reason you should get the problem wrong. If you feel like that's not quite the right answer, plug it in, check it, and see if it is or isn't the right answer. All right, here's a couple of practice problems for you. So let's start with this first one. You will see that you had to distribute the negative 4 to both of those terms. That gives me negative 4 positive 16x. Notice because I have a negative times a negative, the other side does nothing. Now, I don't have any like terms, and I don't need to get anything on the same side, so I can proceed right to those inverse operations. So to get rid of the 4, I add 4 to both sides. Then I have 16x equals negative 112. Divide by 16, and that gives me negative 7. Then you can go through and check to see if that's right. by plugging your -7 in for x and see if that equals -116, which it does. Over here in example 2, notice I have no parentheses, so I don't need to do any distributive property, but I do need to get my values on the same side. So I have a v over here and a v over here. So I'm going to move them to the same side by subtracting 3v on both sides. Unfortunately, when that happens, the 3v's cancel out on both sides, and so I'm just left with -7 equals -7. Well, when the x or y or z cancels out, that's one of those special answers, special situation answers. And in this case, it's a true statement. So the special situation is that this is all real numbers is the solution for this particular problem. If you got a false statement, so maybe you said -7 equals 5, that is not true. So that would be no solution. So just kind of keep an eye on that if your variable goes away in either your equations or inequalities, and decide if the final answer is, or the final statement is, a true or false statement. All right, finally, let's talk about inequalities. So we're going to do the same steps with the distributive property, getting them on both sides, etc. But you need to make sure that you switch. And in this case, both of these examples are non-switching. So over here, I'm going to distribute first. And then because I only have variables on one side, I don't have to do any of that part. I can jump right to isolating my variable, which is getting rid of the other terms in front of my m. So I'm going to subtract 48 on both sides, which I got from the 8 times 6. That gives me -168. Divide by 56. Now, yes, my answer should be negative. That was a problem. Hold on, let's fix that. So if this is a -3, that is fine. And because when I divided, I did not divide by a negative number, I divided by a positive 56, then I'm not going to switch my sign. So this should be a -3. And then notice I have -3 is greater than m. You can switch the sides, the m and the -3, and then you'll want to switch the sign, but that is not a problem that you would switch. The only reason I would rewrite that is if you are more comfortable with the variable in front, which has to do with our graphing. So let's go back and talk about our graphing since I messed up on that particular problem. So if I have m is greater than, or sorry, less than -3, then I'm going to want to start at -3 this time. And I'm going to have an open dot because if it is a greater than or less than symbol, that's going to be your open dot. You can't actually be on -3. And then we want all numbers that are less than -3. So in this case, I'm going to color off to the left over here because all of those numbers are less than -3. All right, looking at my second inequality example, we are going to go ahead and distribute in that first side. So -6 times v and -6 times -7 gives me a positive 42. Then from there, we have to combine our like terms of 42 and -2. So that gives me the 40. Notice I have variables on both sides, so I need to get them on the same side. So I'm going to add 7v to both sides. And then I'm going to go ahead and isolate my variable. So subtract 40, and that gives me a total of -3. Notice you didn't multiply or divide in this particular problem to get v by itself. So we are not going to be switching this at all. And then as a reminder, when you're graphing, remember that your greater than or less than symbols are your open dots, and your closed dots are your greater than or equal to, and your less than or equal to. There are some sample practice problems here with answers if you wanted to try those. And then your graded assignment for actually due on Thursday is your Math Excel on this particular part. So you can start that today and it will be due on Thursday. If you have any questions, don't forget to email me.